Hi class, welcome to the surprise online portion of Math 128, Calculus B. The way that I'm going to start all of these kind of big picture beginnings of all these online lectures is I'll offer kind of what the major points were from the last class and then dive into kind of the outline and big picture of the day. So let's just jump right into it today. So today what we're going to do is shift gears from what we talked about last class, which were sequences, which were just infinite lists of numbers. So today we're going to start talking about things called series, which are infinite sums, in comparison to these lists, which were just item 1, item 2, item 3 separated by commas. In particular for sequences, we discussed when they converge. Another words of saying this was, do all the items towards the end of the sequence or the items really, really far down in that list, if they look identically the same, we call that series or that sequence to be convergent. The other thing that we discussed were if a sequence had two properties, monotonicity, that is whether it is always increasing or decreasing, and if it's also bounded, as in there's a highest value and lowest value in that list. These two items, monotonicity and boundedness, imply that this sequence converges. So these were the major points when we discussed sequences, which were these infinite lists of numbers. Today we're going to shift gears, and what we're going to discuss today are the differences between sequences and series. Just as a spoiler, we have one is an infinite list, the other is an infinite sum. The next thing we're going to talk about is what needs to happen in order for these series or these infinite sums to converge. I also want to emphasize at this point, this is just going to be one of the things that deem a series is potentially convergent. And the last thing we're going to dive into today are some special series, namely the harmonic series and telescoping series. So please check out the other tutorials along with this big picture.